Okay, here's a quick introduction about what relations are and what functions are. So, relations are kind of what they sound like. It's a relationship between an input and an output. So, we've got three vending machines here. And in this vending machine, if you pick a one, you get a Coke. If you press the one button, you get a Coke. If you press the two button, you get a Dr. Pepper. If you press the three button, you get a Fanta. So pretty typical vending machine. We could write these as ordered pairs. One Coke, two DP, and three Fanta. As you see, relations don't have to be numerical. Ours will mostly be numerical, okay? But that's what a relation is. And as you see, this first vending machine would work just fine. You press the button, you know exactly what you're going to get, and life is good. Okay, let's look at the second vending machine. Now, this vending machine works a little different. Okay, if we press the one button, we get a Coke, and either the two or three button is a Dr. Pepper. Now, I want you to take a second to think, the second vending machine, is this a viable vending machine? I want you to think why or why not. It is a viable vending machine because, yes, both of these buttons get us Dr. Pepper, but if we push a button, we know what we're going to get. If we push the one button, we know we're getting Coke. If we push two, we know we're getting a Dr. Pepper, and three, we're getting a Dr. Pepper as well. Now, so the ordered pairs would look like this. Okay, but let's look at this last vending machine. So if we press a 1, we get Coke. If we press a 2, we get a Dr. Pepper. But we could also get a Fanta if we press 2. Is this a viable vending machine? It's not, because yes, we know what we're getting if we press a 1. We know what we're getting if we press a 3. But if we press a 2, we could get a DP, or we could get a Fanta. That's not a viable vending machine, because if I press a 2, I need to know what I'm going to get. So what I've just described to you is the difference between relations that are functions and aren't functions. In a relation that is a function, when you have an input, you know what the output is going to be. Now, sometimes that output will repeat, but the input shouldn't repeat, because every input should only have one output. If you give an input, you should know what you're going to get. Okay? So this and this are functions, but this is not a function. So while we're here in our vending machine, let's go ahead and introduce function notation. Okay, so let's call this our f function. This will be our g function, and this will be our h function. Okay. So if I ask, what is f of 1? What I'm saying is, what is f when 1 is my input? Well, when 1 is my input, I get a Coke. Okay, well, what about g? What about g of 2? Well, when 2 is my input, I get a Dr. Pepper. And I can't do a function notation on this because it's not really a function, because we could say what h of 1 is, we could say what h of 3 is, but h of 2, we don't know. Because if I give you a certain input, it's going to have two possible outputs. On your homework, there'll be sections where they ask you to show that something isn't a function. To do that, all you need to do is give a situation where you have the same input, the same x, and a different output. And that will be enough to show that it's not a function. So that's just a quick introduction to relations and functions.